Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at function pointers in C++. Function pointers are a feature of C++ that's been around since the beginning as far as I know, or for a long time. In C++ 11 we can actually use lambda expressions as a nice alternative, but it's still very important to understand function pointers. So in the same way that we can declare a pointer to a variable in C++, we can declare a pointer to a function like this one, for example, and we can then pass that pointer around, so we can actually in effect pass a block of code to another function, and we'll see a kind of a worked kind of real life type example of that in the next tutorial. Function pointers are actually used even behind the scenes in C++, so if you've been using virtual methods, you've been using them implicitly already, because the virtual keyword is an instruction to cause C++ to create what we call a vtable, virtual table, which is a table of function pointers, so that when you call a method in a child class via a pointer to the parent class type, C++ can do a lookup on the table of function pointers and find the right function to call. So they're very important. Now here I've got a little function called test, and I'm just calling test here. So let's run this, and it says hello. So if you think, well, how could I declare a pointer to this test function? So the first thing we need is a variable of the right type, and then we can point that variable at the function. And what would this type actually look like? Well, we're going to need when we create the type of the variable, the actual pointer to a function, we're not going to need a function name in there. We're just going to need some sort of pointer that can point to a function, in this case with a void return type and with no parameters. So we're going to have the return type in there somewhere. We're going to have the name of the variable, let's call that ptest, and we're going to have the parameter list in there as well somewhere. So this takes no parameters, so we could guess, well, that's going to go after the name of the variable, which will be a correct guess. Now, since it's a pointer, we could think, well, we're going to have the star in there somewhere, probably before the name of the variable. Now, this looks like it could be a candidate for a pointer to a function with void return type and no parameters called ptest. So in other words, the variable is called ptest. But this is also a prototype, like we could use in the header of a class, for a function that takes no parameters and has a return type of void pointer. And we have got void pointers in C++. They're pointers that can point to any type. So this doesn't work. What we need to do is put brackets around the star and the variable name, like this. And this is now a variable called ptest, which is a pointer to a function with a void return type and no parameters. So how would we point this at this test function? Well, we could guess that we could do something like this. So we could, by the way, if you're not familiar with pointer syntax, then do check out my free beginners C++ course, because you kind of need to know basic pointers to understand this. So if you understand pointers, you might guess that, well, we need the address symbol in here and the name of the function, and maybe you need round brackets like that. Well, in fact, we don't need these round brackets. These are a kind of operator that are really just used when you're calling a function, and here we don't want to call it. We just want to set ptest equal to the function, so we don't need the round brackets. But the rest here is a correct guess. This actually works. This points ptest, this variable, to this function. How would we actually call this? Well, again, you might guess that you need the dereference operator, like this. You need the name of the variable, the actual function pointer. And then how are we going to call it? Well, as I just said, we need the kind of brackets operator to call a function, just like we have here. So we put the operator there. Now again, this doesn't work. It's ambiguous, because this could be a call to a function called ptest, which returns a pointer to something, and then we're dereferencing the pointer that's returned. So this could return, for example, a pointer to an int, and then we're dereferencing that pointer to an int, the return value. So we don't want that. What we need is to make sure that this dereference operator applies to this name, this function name, before the brackets operator applies. We need to make sure that this has the higher precedence, and the only way to do that is to put brackets around the whole thing. Now, don't worry if you're thinking this is unusually complicated. It is a little complicated, but we're going to see that we don't actually have to go to quite these lengths. Now, this does in fact work, and I wanted to show you all this to show you how this is all kind of logically built up from basic principles. And in spite of appearances, function pointers are pretty much the simplest way we could possibly implement function pointers in a language like C++. So this works. We've got a second call to hello now. So we're calling this function test via a pointer to it called ptest. But in fact, we can miss out this address symbol here, the ampersand, because this is not ambiguous. All we need is the name of the function. The name of a function is in fact a pointer to that function, which is pretty cool, really. And we also don't need this dereference operator, because if you have a pointer to a function, then it's pretty obvious that if you add brackets that you intend to call the function that pointer points to. So because we don't need the star, we don't need the brackets around this first bit either. All we need is this. So we have the function pointer and we just add brackets to it. So now we can see that if you think of the name of a function as a pointer to that function, then this is like kind of dereferencing the operator and calling the function, and so is this. So there's a nice kind of symmetry there. So we could also initialize this variable when we declare it just by putting equals test, and then we wouldn't need this line here if we were to do that. But of course, a pointer function, unless it's const, can be made to point at different functions. We can, just because it's a variable, we can point at different functions using the equals operator just as we like. But perhaps most commonly, you would want to initialize the function pointer when you declare it. Well, I don't know if that's the most common case, but it's a common case anyway. So often you'll just want to do this, and this works perfectly well. So it's relatively simple when you break it down. It just looks a bit complicated at first. What would we do if the function took some parameters? So clearly you could have a different return type here. This could be a string, reference to string, double, whatever you like, instead of void. If the function takes parameters, for example, let's say int value, and let's output value in here as well, just to do something with it. Now we have to specify those parameters here. We don't need to give the parameters a name. We just need to specify the type of them like this. If we had more parameters, we could put a comma there and, merrily add more in there just as we wish. In this case, we've got one parameter type int, and we just need to specify int there. So this is a comma separated list, just like the parameter list, but we don't actually need to put names for the parameters. So this is now a pointer to a function that takes one parameter of type int and returns void. So this also works. Let's run this, and again we get, well, I did something wrong there. Let's just check. So yeah, I've got to change this as well. Let's put 7 or something in, and of course I've got to change this when I actually call it. Let's put 8. Okay, so now it works. Let's run this. So now we've got hello 7. That's coming from the just normal function call, and we're calling the function with this function pointer here, and we're getting hello 8. So I'll give you a bit more of an exercise with this in the next tutorial, where we'll look at a bit more of an extended example. But because this is a little bit confusing when you first see it, it's really important to practice this. Try creating a function. You can make it take, let's say, a couple of parameters and return something other than void, just to keep things interesting. And then see if you can declare a pointer to that function and then call the actual function via the pointer. So you should be able to do that with the information that you've seen here. And then in the next tutorial, we'll see what we can actually do with this. So until next time, happy coding.